Hello everybody, welcome to a new episode about Java Reflection, and in our case we are developing a JSON serializer. This is the part 4, or the version 4 as I call it, here in the comments. And if you didn't saw my previous videos, please do. I'm doing in sequence, meaning that we are developing a JSON serializer. The main idea is not to learn how to develop per se a JSON serializer, although it's a good project to develop, but the main target is to understand what are the challenges and the technologies behind it, because serialization is used everywhere. When you call a REST API, when, for instance, you are building or using a object relational mapping, there are a lot of different places where a serialization is used. And for that reason, I think to know how to develop it, one, it's has a great utility, since when there are some problems, troubleshooting, when we understand how the internal mechanism works, it's better for us not only to resolve, of course, the issue, but even we start to have additional tools in our mind to develop other kind of projects. When we know how to serialize, maybe sometimes some of the solutions pass for taking a specific object, serialize it, doing some stuff with that, transfer this information to another system, deserialize it, and use it on the other side. There are a lot of situations when knowing how to serialize and deserialization are very useful, at least from my experience of more than 20 years. I find it very useful to know about this, and that's why I've created this series. My previous videos approach how to take an object and serialize using fields. Okay, we have a class called user, and we were serializing different data types for these fields. In this version 4, and as promised, I've added a new component to the object. Until now, the first three versions, for those who didn't see my previous videos, the serialization were about simple objects. I can show you if you didn't saw them. It's something like this. So we receive an object here in the perimeter, and some configuration if you want to format, for instance, the date over a float or a double of a specific field. But here, what this serializer does is just it goes through each one of the fields and make them accessible using reflection. If you don't know about this, please check one of my previous videos about Java Reflection, Introduction to Java Reflection, and I will explain why it is necessary to do this set accessible through. But at the end of the day, it's just for you to be able to access private fields. Okay, now what we want is just to go through each one of the declared fields in a specific class. For instance, in our case, it will be this user. So we have a username, a password, an email with different data types. And in this episode, particularly, I'm adding a composite object, meaning that I have a class with another class, which means the serialization should be recursive, because I will have to serialize this value, this value, this value, and then I have to serialize this object, which, by the way, has or contains other fields, which, by the way, can contain other fields also, and so on and so on. That was the challenge. So in this part 4, as I was saying, we go through all these fields, and we check which data type um, belongs to each field. If it's a string, we just serialize a string. If it's one of the native data types like int, long, which, by the way, they have a kind of a wrapper, which is a class type for the native type, we serialize the number. The difference between serialize a string and the number, it's because the string, when we are serializing to JSON, we need quotes, and for instance, for number, we don't need quotes. It's just the raw value after the symbol. Okay, then we have the boolean. We have to write true or false, and local date, time, and date. And in our last episode, I talked about how to serialize enumerators. Okay, which will, in our case, would be this user type. This represents a user that can be a user of a system, so it can be a regular user, a guest, or for instance, an admin. Okay, this is a summary of what we have done on our previous episodes. If you already saw them, so I will go now straight forward to the implementation of this one. On our latest episode, I just refactored the code to be more clear about the intentions. So it will be easier for this episode to create a composite object. So what I did, I just refactored the user. The user previously had these 5 fields: username, password, email, active, and then he had, okay, not these 5, these 4. The 5, it's now a container, which is this one, user info. It's another object which has the birth date, age, salary, and user type. So our previous version, all these fields were all contained here. Now I've split, I extracted from this user these 4 fields, and I create another object. And of course, on the user, now it has a object inside here. What is interesting here is that we know how to serialize a string, a boolean, and we know how to serialize an object. But in our implementation, we didn't implement serializing an object inside another object. Okay, that's what we will be doing in this episode. So let's see what was done. So in our serializer, firstly, of course, it was the split of this user to 2 different objects. So user info belongs to the user, meaning that user has username, password, email, and active, which are 4 common fields when you are managing users, mainly for authentication and authorization purpose. And user info, it's additional data, personal information like the birth date, the age. Of course, this is redundant. This integer exists only to make sure that we test the integer. Of course, from the birth date, we can extract the age. And a salary, so we can have a double, and user type, we have an enum. But all this information are more user info. Of course, you can argue, okay, maybe we should move this user type to the user since it's a type of user. And I agree, but I'll just split, very simple, just for educational purpose. But of course, you can always challenge my solution and my decisions. But remember that my target is to learn, or to learn for you, of course, for me to teach how to develop a serializer and what are the challenges for the different data types, composite objects, and so on. So let's see the implementation. So in this implementation on the serializer, I just did a little more refactor of the code, a smaller one. We previously we had this case with string, and I was just calling this line. And in our previous version, I didn't have this, and the reason was that now it's because of the new entry that I created it for the, so we can test for class inside class. But let's return here. I'll explain in a moment the reason. So we have, I just make sure that after I serialize a value independently of the data type, I just append, of course, the comma, and then I continues, meaning that I will process the next field. And I will explain in a moment why. So in our previous version, we had all this switch case. We have the specific if for the enumerator, but I added now this for a class. And what I wanted here was just to avoid to serialize classes that belong to, at least at this time, I just want to make sure that only class that I develop will be included in this realization. So I'm avoiding any class that belongs to a package. I'm getting the name, not the simple name of the class that starts with Java. And if you look into the import, all the Java class usually start with a parent package Java. So if I make sure that the class that I'm testing here doesn't start with the Java in the package name, so probably it will be a class created by me, or in this project, a custom made class. Of course, this is not a good solution, but for this episode, version 4, we are learning how to implement a recursive serialization. It's a good start, because at the end of the day, and now you will understand why, for instance, some of the classes, it's not the only reason, but why some of the classes, when we are using serialization, they require that we implement an interface called serializable. And this interface doesn't have any method. It's just a name. It's a kind of a tag. And was before the Java introduced the annotations in the language. After that, we usually the common frameworks for serialization. They have a specific annotation, meaning I want to serialize that class. The reason is to avoid this kind of tricks that I'm doing here to make sure that I'm serializing a class of my project and not all the classes, for instance, that exist in Java. Of course, there are a lot of discussion that we can have here, but I just wanted to make sure that you understand the reason behind use of the serializable in legacy code or using annotations like JSON serializable or something like that, that we put on specific class so the serializer knows if it should serialize or not a specific class that exists in a specific field, for instance, or a specific get of a class. And again, it's not good practice to serialize fields like we were doing here. That's why in a future version, version 7, I will switch from fields to gets. The reason is sometimes we don't want to serialize the internals of an object. We just want to serialize what the object allows us to be external, and that in Java is being implemented by using the gets of the fields. Okay, so let's go to the implementation. So I've added only this part, and this is quite simple. After the refactor we did on a previous episode, meaning that we have specific methods just to serialize. And for those who didn't see this method, serialize number, I can show you. It's very simple. It just receives, let's say, serialize a string, receives the object that contains the value, of course, the field, because you need the data type, and then and the string builder, which is the container of our JSON. So at the end of the day, just this line, meaning that we just want to add this code. Then we get from the value of this field in this object, we use the get, and again we append the code. It's only this. Of course, when you have an enumerator, it's good practice to do this enum. And please see my previous episode. I explained this in more detail. Or for instance, when we are using a double or a date, maybe we want to apply a kind of a format. So in that case, I've added this parameter JSON serializer configuration, and what this class does is just to have formats that we can apply to dates, doubles, and floats. It's only that, but it's quite simple. Again, if you want the code, please send me a message. I'm not putting the links on GitHub, but I can create a repository on GitHub and put this code there so I can download it. But usually, if you are following my series, you can develop yourself this code. It's quite simple, and it's a great exercise. But my main intention is for you to understand how it works more than you write it. But if you want to write it, be free, and I'm available to send you the code if you think it's useful for you. So again, let's return to our JSON serializer. Again, probably it's my fourth time that I'm saying this. Okay, let's try for the fourth or fifth time. So I go through each field, check, okay, which data type do we have? If it's a string, serialize a string, serialize a number, boolean, local date time, date, enumerate. Now, what happens if it's not uh, neither one of these data types that we saw previously? Probably it will be a class. Of course, it can be, for instance, a collection or maybe an hash set or hash table, but that it will be the next episode. I'm delaying the serialization of collections after after knowing how to serialize every data type, because a collection is a set of data types. And first we should know how to serialize every data type, and then we go to the collections, because at the end of the day, serialize a collection is just to going through each item of that collection and serialize the data type that's inside of it. Okay, that's why I'm delaying to the next episode. So let's again return to this. So if it's an object that doesn't start with Java, meaning that hypothetically it's one of our own classes that want to serialize, that we pass on the parameter, there is a very simple thing to do. We just serialize it. We call it recursively this because it returns a string. So I just ask him, okay, please serialize it. And this method serialize and returns a JSON, meaning that for this user, okay, when you reach this data type, it says, okay, it's a class, so I will serialize it. And what this serialization does is just serialize this object and to JSON. So I I take this content and I set to this field. And if this user info, it's not the case, but if it contained a kind of another object, it will be serialized also, and the same logical recursively. I'm not saying right, probably. So I just serialize it, which means when I call this method, it will call again this, but now the object, it's not user, but the user type. Sorry, the user info, okay, which will serialize these ones, and you'll return the JSON. And after we return the JSON, what I'm doing, I'm just append to the current JSON of the user, which is the parent, with the field, with this field here, the user info, meaning that user info will receive, okay, the result of this serialization, like the other fields. At the end of the day, it's the same thing. If you look into here, I'm just doing, okay, serialize local date time, and I'm putting here JSON, and this JSON will be uh, appended with inside this method. But I could have used the same logic, meaning that I could have put the JSON outside and call the serialize, and this serialize return a string. Maybe I will do it on the next episode, second or third refactoring of our code, so it will be coherent, let's say, between all the methods. But I hope you understand how simple and how elegant this solution is after a small refactor that we did in our previous episode. So I just call it, okay, please serialize this field, give me the string, and I will concatenate to our current JSON. And as you know, if you saw my previous episode, the first thing that is always doing is just to serialize the field name, meaning the name of the field. Then we add the separator from the field name for the value, which means that for each one, it will be just the key value. And that's why we have this continue here, to make sure that after we serialize the specific field, it goes to the next. And for each one of these data types, which if you look into this pattern, it's quite simple. We just have this loop, make sure that the accessibility is true, and then we just serialize the left part of the field, meaning the key, and then we do a switch. We just test for each data type, or for all the data types that will allow in our serializer. These are the native-ish ones, like I usually say, because local date is not a kind of a native, it's a class, but it's a special class. It's immutable class, like all local date time, string, they are class, but they are very specific in Java. This for enumerators, and now for the any other data type, class type that doesn't belong to the Java package. Okay, again, there can be some discussion here, but that's the decision we're taking at this time. Remember that a good development is an interactive or incremental development. Don't try to say, okay, but there are other cases. Okay, but let's make sure this one works. Then on the next one, we review our code and we try to include other features, even if you have to refactor the previous one. But we are confident, and our mind now has more knowledge about it, more experience, so it's easier to change than try to make everything works, and then when it fails, we start to review our uh, mind process to understand when did we fail, and it's very difficult. So usually go through small increments. It's the better approach. So let's see how this is working after all this talk. So we have here now the user with these four fields, but now we are instantiating another object that we pass on the constructor. It's the user, our previous class, which now receives here another object that will be, so we have an object inside an object. So we expect on the output to see a JSON with a JSON inside. Let's play. Okay, and you can see the username, the first field of the user, the password, the email, the boolean. You can see there are no codes here. And now you can see that we have our object user info, and we can check it is this user info here, which is an object. So if it's an object, it it will receive a complete serialization, like starting from zero. So we can see here an object serialized inside this object here. Okay. So this is a property of the class behind this field, which is a date with this format, an integer. You can see that it's working, salary, user type. What is great about this solution is that this first part of the code that we developed for a simple object now works for any object. We can use it for any object, even when these objects are inside objects. Okay, I know I talk a lot on this video. I talk more than I show because at the end of the day, I just developed this part of code here and did a small refactor here to make sure there will be no conflicts between the types. Okay, and I hope you liked this video. I hope you are learning. Be free to comment. Please subscribe, share it with your friends, propose any subject that you want to be discussed. I have a lot in the queue to to publish on YouTube. Sometimes I'll take days. Probably there are other times that you'll see I will publish every day. It depends. Okay. So again, thank you for watching, and I see you on my next video.